The Marlowe Playground is a very nice tool in which you can write Marlowe contracts in various languages, inspect them, simulate them, play with them. So we will go into depth in the next lecture, but now I just want to show how we can simulate the contract we just saw in Marlowe Run here in the playground. So when you start going to the playground, see you can open an existing project or open an example, so we will do that. And you can choose a development environment. So you can write your Marlowe contracts in JavaScript or in Haskell or directly in Marlowe or in Blockly, which is a graphical tool. So we will look at those options in the next lecture. So let's open an example. And I believe the one we tried in Marlowe Run is this one, Contract for Differences. Here's also a second version with Oracle. So the difference between those two is, I think, that here, as in what we did in Marlowe Run, the Oracle party is an actual party. So a person that has to explicitly make this decision and submit it to the blockchain, whereas here it's basically a simulated automatic Oracle. But let's choose this one. And now it doesn't really matter. For example, we can just do Marlowe. So here we see the contract, the full contract in Marlowe of this example. We could look at it in this block form and then manipulate it, change things. But as I said, we'll look at that in the next lecture. So let's instead send it to the simulator. And now similar to what we had to do in Marlowe Run before we could start it, we could choose or change the parameters. And in contrast to Marlowe Run, where we couldn't manipulate these deadlines, here I actually could, I think, put something else in there. I'm not sure. No, it seems not. So here they are also, no, I can actually. Okay, but let's just leave them as is. So I think it's the same as before, 5 minutes, 10 minutes, 15 minutes, and so on. And let's just pick the same amounts for the deposits by party and counterparty here. And then start the simulation. And in Marlowe Run, we had one instance of Marlowe Run for each participant, for each party. In contrast to that, here in the playground, we have a somewhat godlike perspective where we play all parties simultaneously. And we can even turn back time and go back a couple of steps and make a different decision and see what would happen then. But first, let's do exactly what we did in Marlowe Run as well. So first action that can be performed is that participant party deposits 1,000. And alternatively, we could wait. We could wait for 1 minute or until the next timeout or even to the end of the contract as a whole. So let's just make the deposit. And now this happened. We see something moved here on the left-hand side. So each time the contract goes through a transition, the contract itself, the remaining contract also changes. So it normally gets shorter and shorter until in the end it's just empty, basically. So now it's counterparty's turn to make the deposit. So let's do that. So now that both deposits have been made, there is no action for any of the participants. That's the same as it was in Marlowe Run, where we had to wait. So we could now wait 1 minute, but I think in total we would now have to wait for almost 15 minutes. So to shorten this, or each time I click here, the current time should change. So if I click again, you can observe it's changing. But I can also directly jump to the next timeout, which in this case is the end of the waiting period. And now I get to the part where the Oracle can set the first price point. So let's do the same values as before, so 500 and 400, so 500 ADA here. Now we are in this waiting period again, so let's immediately jump to its end. Now comes the second price point. And let's do this. And now the contract is done. So no valid inputs are possible anymore. So let's check this transaction log to see what actually happens. So all the actions we performed are listed here. Party deposited 1,000, counterparty deposited 1,000. Oracle shows value 500 ADA, Oracle shows value 400 ADA, and here we see the consequences. So after this choice, because the price dropped, party will get the difference. So the contract pays 100 from the internal account of counterparty to the internal account of party, and then the internal accounts are paid back to the actual wallet. So then pays 900 ADA, the remaining 900 ADA from the internal account of counterparty to counterparty wallet, and now the 1,100 ADA from the internal account of party to the party wallet. So we can see, we can observe the same effect that we also saw in Marlowe Run. Of course, here it's not actually happening on the blockchain, it's a simulated blockchain. But the nice thing is that it's much faster. We don't have to wait all these waiting periods. We can just click to the next timeout. And another nice part is we can also go back. So for example, observe what would have happened if the price hadn't gone down to 400, but maybe instead gone up to 700. And we see in this case, counterparty gets the difference. So counterparty receives 1,200 in the end, and party receives 800. So this is a very nice tool to explore a contract, try various scenarios. I don't want to try everything now, but one more thing I can show you is what happens if one of the deadlines is reached. So for example, let's say party makes the deposit, but now counterparty doesn't. So if we wait, I could also do wait to next timeout. Then at some point when the timeout is reached, the contract ends, and we see here in the log, first party deposited, and then after the timeout was reached, party gets reimbursed. So there's a payment from the internal account of party to party's wallet. We will see that the playground has much more to offer, so you can also do static analysis with the playground, but we'll look at that next time. So as exercises, I would encourage you to try what I demonstrated in the lecture. So try to play with the example contracts in both Marlowe Run and in the Marlowe Playground, and just get a feeling for how it works. And in particular, try various paths through the possible actions in this example contract in the playground and see what the different effects will be. This concludes today's lecture. Thank you very much for your attention.